When people hear the word mutations, they usually think of a negative, something negative like a genetic disease, sickle cell anemia, hemophilia. When I say mutation, I refer to a change in the genetic information, the gene. This change can happen because the enzyme that makes copy of the gene misreads and puts one base that doesn't correspond. When that happens, the information content of the gene changes. And this change is not necessarily negative. It can be positive. It depends on the context of the environment. For example, in the case of the sickle cell anemia, is a disease, is a genetic change, mutation that causes the shape of the erythrocyte to be different. In this shape, as a cycle, it causes a low affinity for carrying the oxygen, which is really bad for the people who carry the mutation. But in the environment where the parasite, malaria parasite is present, this parasite cannot be housed in the erythrocytes with the sickle shape. So and that's being good for the people who carry the disease. And this is just one example. There are many other examples. If you think, for example, in the origins of life, where there might be genes that need to explore different environments. For example, a gene that codes for house. Those molecules or individuals carrying that gene will explore different niches, which was needed at the origins of life. If for mistake the enzyme copying it changed the house to a spouse, then now these molecules will look for a partner and not for a niche. And then they will probably reproduce more. As they reproduce more, just by random, they will pass more into future generations. And this is how evolution happens. It's using the genetic information that is generated by mutations to select different information. And it's how we have come from the origins of life until today. Thank you.
Judges.
I liked your house to spouse message. That worked very well. A house performs a specific function. A spouse performs a specific function. They're very different. That worked really well. And I liked the message that you conveyed that mutations can be useful and they can be harmful, and it depends on the context.
Yeah, it was a very, very nice sort of size of message that fit nicely in the box of the 3-minute talk. You were unhurried. You got to your point, and I liked the props because they were very sort of lo-fi or whatever. Just the fact that they were just kind of cut out of colored paper, and it looked like you could have done it over breakfast this morning. But I liked that because they were very kind of simple and non-threatening, and made it very friendly. And you seemed very sort of approachable in your delivery, like somebody that you would want to sit next to on a plane and just kind of hear about what they do. So.
You started out very poised, very clear. I loved it, and you maintain that throughout. You very few ums, ands, all of those sorts of things. You've clearly done this before. I like very much your visual aid, and I recognize that you're under some constraints here, and probably if you had the ability to put those up like on a whiteboard or something, same thing. I love the little cutouts. But same thing, just so you don't get tired of holding your arm out, because I know 3 minutes of that, I'd be really tired. So good job. That was great.
Thank you. Mutations can affect us in negative ways and also in positive ways. When I say mutation, I refer to a change that can happen in the genetic information. This change can occur because the protein, the enzyme that copies the information of the gene, can make a mistake and introduce the wrong letter, and therefore the information changed. Because of this double sword effect of the mutation, it needs to be regulated. And there are different ways to regulate the effect of mutation. One can be the mutation sort of realizes that made a mistake and correct the mistake. But not all the enzymes that copy the DNA correct the mistakes. Many doesn't, like the viruses, for example. Other way in which the effect of the mutation can be regulated is by the fact that proteins, the product of the genes are encoded by a 3-letter code. And then the amino acids that makes the proteins have more than one set of 3 letters. That means that one change here not necessarily imply a change in the protein. But if it does, and you end up with a protein with a bad amino acid, still, it happens that the protein to make the function, it folds. And then this shape is held by chemical interactions. And then the function, for example, like it gets like a knot, and the function can still be performed well despite the mutation in there. Another way in which the effect of mutation can be regulated is by the fact that the genes and the gene products interact. And the way they interact can cause the same mutation to have different effects. And then this is how, since the origins of life until today, mutations has allowed evolution to happen. Thank you.
Linda.
I enjoyed your presentation. I'm trying to think of a good question to ask you because the subject that you're addressing is so deeply complex. And I think I'm going to pass the mic to my other judges and let them pass it back to me.
David or Lisa.
Well, it's really fun what you're doing with the letters because people talk about DNA as a language and the code as letters, but it's very visceral when you show it like that. I don't really have any questions for you. I enjoyed the talk.
Thank you.
I don't really either. And this is interesting that we're all kind of a little stumped, and I think it perhaps has something to do with the fact that you gave a very clear explanation of this and very easily understood that mutations can be both beneficial and detrimental and contribute to the evolution of organisms. So thank you. Good job.
Thank you.
Thanks again, Carolina.